Here we want to look at solving polynomial equations by graphing. Now we mentioned this the other day. We didn't call it the fundamental theorem of algebra, but it is. Young Carl Friedrich Gauss. He told us that every polynomial equation of degree n has n solutions. And that's going to be helpful for us when we're trying to solve polynomial equations by graphing. I mean, think about this. Let's say we got the graph of some polynomial function p of x. We know the degree. Yesterday we saw that since this thing turns 1, 2, 3 times, it has a degree of 4. That means that we have 4 solutions to the polynomial equation. Problem is, I don't see a polynomial equation. But we can write one, and that'll help us figure out what p of x is. See, remember when we were graphing, how do you find x-intercepts? You got to let y equal 0. So the equation I'm going to make is p of x equals 0. And to make it, I'm going to look at all these x-intercepts. Notice that there's 1, 2, 3, 4 of them. Those would be our 4 solutions that we need. Now, knowing what those x-intercepts are, that means we know what their factors are. So if negative 5 over here is an x-intercept of p of x, that means that x plus 5 is one of the factors of p of x. If negative 4 is an x-intercept, then x plus 4 is a factor. If 0 is an x-intercept, then x minus 0, or just x, is a factor. And if 2 is an x-intercept, then x minus 2 is a factor for our equation. Now, I'll let you take the time to multiply this out. It'd be a good idea to pause the video, grab a piece of scratch paper, practice multiplying this out. But when you're finished, what you should get is x to the 4th plus 11x to the 3rd plus 38x squared plus 40x equals 0. We were asked to find what p of x is. Well, we did. Our p of x is going to be this polynomial equation. X to the 4th, 11x cubed, 38x squared, and 40x. But ultimately, what I want you to be able to do is to solve an equation by using your graphing calculator, or Desmos. So to do that, if we want to solve 6x cubed plus x squared minus 11x minus 6 equals 0, the first thing we should do is graph the polynomial. So in Desmos, I'm just going to go y equals all of that polynomial. 6x to the 3rd plus x squared minus 11x and minus 6. And we get a nice graph of our cubic function. Now, if we want to find the solutions, all we have to do is find x-intercepts. So, highlighting our important numbers, our x-intercepts, we can see what all of our solutions are going to be. The first one, we have that x-intercept at negative 1, 0. That means the x is negative 1. When we have that x-intercept at negative 0.66667, we should recognize that that's negative 2/3. And finally, when we have our x-intercept at 1.50, then our solution is 1.5. It's just that easy to solve polynomials. So let's check out a couple special cases that we might run into. First of all, if we want to solve by graphing x cubed plus x squared minus 8x minus 12 equals 0, we're going to graph the polynomial y equals that x cubed plus x squared minus 8x minus 12. We look for our x-intercepts here and here, and we see that we've only got 2 of them. However, we should be expecting 3. The degree of the polynomial here is 3, so we should be expecting 3 solutions. In fact, Gauss said there has to be 3 solutions. One of them is over here at x equals 3. One of them is over here at x equals -2, but where's the other one? And in fact, the other one is also going to be x equals -2. How we can tell that is by paying attention to the graph. We see that on the left-hand side of the graph, our function is negative, and on the right hand, it's also negative. Anytime that you have a curve that comes up and just touches the x-axis and then goes back away from it and doesn't go across it, then that's where we end up with this double zero. Gauss said we have to have 3 solutions, and we do. He didn't say that all those solutions had to be different, and so we have 2 of them that are the same. Finally, let's take a look at this equation where we got x to the 4th plus x cubed minus x squared equals 4x plus 12. And now we have a polynomial equation, but it doesn't equal 0, so we can't be using the x-intercepts. However, we can. A real easy way to work around this is just get it to equal 0. What I'm going to do is take that 4x plus 12 and bring it to the other side. So we'll still start with x to the 4th plus x cubed minus x squared. But to get rid of that 4x on the right side, we have to subtract it to bring it over to the left side. And to get rid of that 12 on the right side, we have to subtract it to bring it over to the left side. Then we have an equation that does equal 0. Now we can go over to our graphing calculator and solve it. So we're going to type in the equation, and this is what the graph looks like. Now, there's a problem here. We have a degree of 4 in our polynomial, so we should be expecting 4 solutions. However, when we look at Desmos, we only see that we get 2 solutions. There's one of them here at -2, and there's one of them here at +2. Where are the other 2? Well, the other 2 happen to be imaginary solutions. We know that when we have a 4th degree polynomial, this thing should turn 3 times, and it does. Here's 1 turn, 2 turns, 3 turns. The thing is, that turn in the middle, it doesn't turn enough to bring it back up to the x-axis. So we don't have any x-intercepts from that. What that means for us is that the 2 x-intercepts that we would have got if this part would have come back up and back down, those 2 don't exist. They're not real. They're imaginary solutions. Now, for the time being, we are going to get into finding those imaginary solutions, but for right now, I don't want you to worry about them. I only want you to find our 2 real solutions to our equation right here.